evening, my viewers. I'm here today to show you how to apply equation of linear motion, the Suvat equation. Now, if you can remember from my previous video, I told you that the four equations, two start with V, two of the equations start with V, and two start with S. So, I'm going to remind you about all this formula. Let's start from the first one. V equals to U. V equals to U plus AT. This is the first equation. The second one is V squared equals to U squared plus 2AS. While the third one is S equals to UT plus half AT squared. So, and the last but not the least is S equals to open bracket U plus V over 2 times time. So, let's see our next page. Now, so in our next page, we want to talk about statement and implications. What are the statements we need to look out for before applying this equation? The first one is whenever they mention from rest. When they mention that a body starts from rest, it means that in its initial velocity U is the initial velocity, the velocity at which the body starts the motion. So it started from rest. This is what 0 meter per second. And they can also tell us that a body goes to rest. If a body goes to rest, that means the body is no longer moving. That means its final velocity equals to 0 in meter per second. And another synonym of rest is when they say a body goes to halt. A body goes to halt, that means the body goes to rest. It's still the same thing as V equals to 0 meter per second. What if they tell us that there is a retardation? If there is a retardation, then it means that the acceleration of the body is negative. So we're going to change our A to minus A in the equation. And that goes with the same thing with deceleration also. They mean the same thing. What about if they talk about uniform speed or constant speed? If you talk about uniform speed or constant speed, they are talking that U and V are equal. And when U and V are equal, it means that the acceleration is 0. So let's see how to apply this to questions. So I'm going to go to two typical examination questions. The first one is this: a train with an initial velocity of 20 meters per second. So give us that the train has initial velocity 20 meters per second. That's U equals to 0, 20 meters per second. Good. Is subjected to a uniform deceleration. You can see that's a deceleration. That means our A is going to be negative. So they give us 2 meters per second square. So that means our A is going to be minus 2 meters per second squared. Then they now told us, they're asking us the time required to bring the train to a complete halt. Can you see the word there? Halt. H-A-L-T. That means to rest. So for rest, we know that V, final velocity, equals to 0 meter per second. So now they're asking us to find time. From the Suvat equation, we can look at what will be the equation that combines UA and VT. If you look at it here, the equation that combines UA and VT is just this first equation. So that's what we're going to apply. V equal to U plus AT. So let's go back there. We have V equals to U plus AT. But we know that our acceleration is negative. So, and our U is 0. So if you make the substitution, V equals to 0. And U is 20 meters per second. That's 20. 20. And this plus A is minus 2. Minus 2T. So this is just a simple linear equation. So I can bring this 2T to this side. I have minus 2T become what? 2T equals to 20. So I divide both sides by 2. Divide by 2, divided by 2, then t equals to 10 seconds. That means a train that is moving with a uniform velocity of 20 meters per second, that is moving with an initial velocity of 20 meters per second, and brakes are applied in such a way that it slows down. So how long will it take the body to stop? That's the meaning. So if the deceleration is 2 meters per second square, so that means the body will stop after 10 seconds. So let's look at another question here now. So in this question, a car accelerates uniformly from rest. Can you see the keyword? From rest. From rest means that u equals to what? 0 meter per second. And they told us that at 3 meter per second square, that means it accelerates at 3 meter per second square. That's our acceleration, 3 meter per second square. They are asking us what is its velocity. That is, they want to know its v, final velocity, after traveling a distance of 24 meters, after covering a distance of 24 meters. So we look at what formula combine u, a, v, and s. Let's go and check. U, a, v, and s. U, a, v, and s. This is the equation. So we take that equation, which is equation is v square equals to u square plus 2as. We make our substitution. V is the unknown, what we are looking for, and u square, that is 0 square plus 2 times, what's our acceleration? 3 times, what's the distance? 24. So what does that mean? It means I'm going to find square root. This is v square, so I'm going to find v, which is v is going to be square root of the other side. 2 times 3, 2 times 3 is 6. 6 times 24 is 144. This is 144. Square root of 144, which is 12 meters per second. That means after the acceleration, the body will attain the speed of 12 meters per second. Thank you for listening. You can try further questions by noticing the keywords and making the right substitution. Thank you.